Hi everyone, we are now going to go over arithmetic sequences and series. So make sure that you have a pen ready as I'm going to start right away. So arithmetic sequences. So let's remind ourselves what is arithmetic sequence. So I'll give you an example of an arithmetic sequence. So it's 1, 4, 7, 10, 13, 16, and so on and so forth. So if we observe the pattern over here, we can notice that there is a common difference of 3. So each time I'm having to add 3, and this is known as an arithmetic sequence where, yes, so there's a common difference. So this is known as a common difference. And it's very important that you understand or recognize this term. Whenever you hear common difference, you know right away it's an arithmetic sequence. And it's called arithmetic because you can add or subtract. So another sequence, for example, would be like 15, 11, 7, 3, -1. And it's important to remember the common difference doesn't have to be positive, it could be negative as well. So in this case, it's -4, -4, -4, -4, and you could go on forever. So this is known as the common difference. So what is the general equation for an arithmetic sequence? So the general equation for an arithmetic sequence is the following. So we write it's un is equal to u1 plus dn minus 1. So un is like the nth term, stands for the nth term, or you could say even the last term, depending on what you're given. So for example, the third term, u3, in this sequence would be 7. So in this sequence, u3 would be 7. So n in this case would be 3 because it is the first, second, third term of this sequence. All right. U1 is obviously, since it's 1, it's the first term of the sequence. Right. D is the common difference. So I'm just going to write DIFF. And n is the I guess the sequence number, the sequence position. The sequence number is sequence position. So for example, 15 is in the first position, so n would be 1. 11 in this case would be the second position, so n is 2. 3 in this case is in the fourth position, so n would be 4. U4, however, would be 3, right? Because the fourth term is this one, which is equal to 3. All right? So I hope that makes sense. One thing I wanted to show you with arithmetic sequences is actually what it sort of looks like in the graph, and a special equation that I'm going to derive that's not actually in your notes or even in the IB formula booklet, but it's going to make your lives a lot easier. So let's just look at a particular sequence. So let's say UN, and let's look at N. So N will always be like, it'll start from 1 and continue forward, 4, 5. So the sequence I want to look at is this one: 1, 4, 7, 10, 13. Okay. So imagine that we actually graph this. Imagine if we actually graph this right here. So if we graph this, let me just go back here. So if we graph this, so this would be n over here, and this would be un over here. So what we notice is that if this is 1, 2, 3, 4, 5, for example, I don't know if I'll get to graph all of them, but let's just say this is 1 over here. That's our 1 point. So the second point is 2, 4, so 2, so 1, 2, so 2, 3, 4. So that's 4. So this point would be right there. 3, 7. So 1, 5, 6, 7. So that would be right there. So this would be right there. And 4, 10. So 1, 2, 3. That's 10. And that would be right there. So if you observe, it actually kind of forms a linear path, and it's not just actually kind of, it forms a linear path. So if I plot this with, say, a red one, let's see if this is going to work or not. Oh, no, that's not, that's too big. But anyways, my point is that it basically forms a linear path. And what's really helpful from this linear path, what we can actually observe, is that the slope of this path, so in other words, let's say the slope of this path, which we usually call m, is actually the common difference d. Okay, so usually when we have m, we say it's y2 minus y1 over x2 minus x1. But in this case, so in a very similar fashion, our common difference d is the following equation, which I really, really want you to write down in your notes. It's uj minus uk over j minus k. So uj and uk are basically any 2 points. So in other words, let's say we take that point and that point. It doesn't really matter. We call the higher point, I prefer to call the higher point j, but it doesn't have to be. It could be the lower point. But uj is the coordinate, is the y, is basically the term minus uk. So in other words, it's like y2 minus y1, and j minus k is just the end term, so it's x2 minus x1, and that's a similarity over here. So if you're given two different positions on the sequence, or two different terms in the sequence, you can determine the common difference pretty much immediately using this equation. I can give you a quick example. Well, actually, no. In the next video, we'll go over some examples of how to use this formula, how to use the sequence formula, which once again I'm going to write over here. The sequence formula is un is equal to u1 plus dn minus 1. So how can we use this formula as well as this new formula that's derived, which is very, very important. I highly recommend that you write this down. And so how can we use these two formulas together and solve some problems? All right, so we'll go over that in the next video.